In this video, we'll talk a little bit about labor demand elasticity. The short-run own wage elasticity is defined to be the percent change in employment in the short run divided by the percent change in the wage. This can be written as the change in employment in the short run divided by the level of employment. That's how we measure the percent change in something. Well, we multiply that by 100. We measure the percent change in the wage by the change in W over W times 100, which simplifies to this ratio. We take the ratio of the change in employment to the level divided by the change in the wage to the level of the wage. With a little bit of algebraic manipulation, we can write this as the ratio of the change in employment to the change in wage times the ratio of the wage to the level of employment in the short run. And this gives us a measure of elasticity at any point. We can do the same thing for the long run, and the definitions are basically the same, except here we're dealing with long run employment levels. We say that labor demand is elastic in either the short run or the long run. If the absolute value of the elasticity is greater than 1, it's inelastic if the absolute value of elasticity is less than 1, and we say it's unit elastic if the absolute value equals 1. Let's compare the short run and the long run elasticity. In the short run, there are some changes you can make by substituting different types of variable inputs for each other, but you can't change capital for labor because in the short run, capital is fixed. In the long run, you can substitute capital for labor. So in the short run, when the wage goes up, you end up with a relatively small change in the quantity of labor demanded. In the long run, the quantity of labor demanded falls by a greater amount because you can now replace labor with capital. We should be careful, though, not to confuse elasticity and slope. To see why that's an issue, let's talk a little bit about percent changes. When we go from 1 to 2, that's 100% increase in the level of some variable. From 2 to 3 is a 50% increase. From 3 to 4 is a 33% increase. From 4 to 5 is a 25% increase. From 10 to 11 would be a 10% increase. And what we see in general here is that as we increase this variable by 1 unit, the percent change gets smaller the larger the initial starting point. So the larger is the base value, the smaller will be the percent change for the exact same change in quantity. Now, if we look at a downward sloping linear demand curve, at the top of the curve, we notice that the wage is relatively high, so percent changes in the wage will be relatively low. But at the same time, the level of quantity is low in the top left portion of the demand curve, so we end up with a relatively large percent change in quantity. As we move downward and to the right, those reverse. Because the level of quantity is getting larger and larger, the percent change is getting smaller. And similarly, because the wage is getting lower, the percent change in the wage becomes larger. So what we see along a linear demand curve is at the top portion of the curve, it's relatively elastic. Elasticity declines continuously till you get to some point in the middle where it's unit elastic. Beyond that, it becomes inelastic.